In our next question, I want to briefly talk about how we can combine multiple queries. It is often the case that we want to combine queries. Here, we're going to take a look at union, intersect, and accept, and we're going to come back to this idea of tuple spaces. Remember, when I select from a SQL data source, the operative model is not the NumPy operative model, which is contiguous, homogeneous, n-dimensional data with some sort of interpretive view. Or pandas, like index one-dimensional data sets with some index-level operations. The operative model is sets of tuples and operations I can perform on those sets of tuples. So here you can see this constructed multiple tuples, ABC 1, 2, 3, DEF 4, 5, 6, XYZ 7, 8, 9, and I selected every tuple that I saw. And I could select every distinct tuple that I see and eliminate any duplicates I might see. So if I saw this value twice, you can see I can eliminate that duplicated value. I don't see more than one ABC 1, 2, 3. I can customize what the distinction should be done on, and so I can do a little bit of customization in terms of what is considered distinct, but fundamentally I'm still operating on the space of a bunch of tuples and how I can reduce that. Well, if I had multiple queries and I want to join those multiple queries together, one thing I could do is I could create a temporary table, and I could insert into that temporary table twice. So here, I could do a select into and a select into, but that's not necessarily what I want to do. Maybe I want to do this in one expression without creating a temporary table. SQL gives me the ability to union queries together. So I can perform one full query here, and I can perform one full query here, and take those tuple spaces and union them. And if there is an overlap, note that the overlap was removed. There's only one instance of ABC 179, but I can also union all, and I can get every instance of that. So naively, or I would say by default, what happens when you union is you're actually looking at something akin to a set union. These really are tuple spaces. These are really sets of tuples that you're working with. If I can union, then it makes sense that I should also be able to find the intersection, give me all of the tuples that are in one and also in the other. And if there are duplicates, the intersect all doesn't seem to really do anything. Like here, I still get only one row, even though there's a duplicate between these two. Well, what the intersect all is about is duplicates within these tuple spaces. So when I do this by default, the DEF 4, 5, 6 is the only thing that's in common. By default, what intersect will give me is only one entry for that. It'll eliminate all the duplicates. Intersect all will give me the minimum number of times something was duplicated in the intersection. So here, if I had 5 of them on one side and 3 of them on the other, I'll get 3. I'll get the minimum of this. And similarly, I can do set subtraction as well. I can do an accept. And so this takes all of the tuples here minus the tuples here. And you can think, well, the all is going to do sort of what you think it would do for the intersect if there are duplicates duplicates within these. What the accept all does is it gives you the maximum number of the duplicates that you see after performing the subtraction. And so here, this value, let's remove this value here. This value should exist after the subtraction, and you can see here it gets preserved in terms of the number of times it appears. And so here we saw very briefly how we can combine queries together, union, intersect, and accept, and it reinforces our notion of the most fundamental thing we have to think of when we think about SQL. It is a tool for working with out-of-core, out-of-memory data sets, being very careful about how many disk reads you do, where the operative model for how you design the query is a model of tuple spaces, not the pandas model, which is about like index one-dimensional data sets.